Edmund Halley really got interested in eclipses and started doing detailed predictions of their eclipse paths. And in fact, he's the first one that produced some of these maps of the moon shadow and the path of it across England during the 1700s. So since then, there's been an explosion, especially with computers, digital computers in the last couple of decades. Yes?
Try to get an interesting question. Let's say that you're in charge of an event, okay? On the day of totality. What do you do with the people that are waiting because you've taken off to go to the eclipse sky?
Make sure they don't know your address. I think you've got to spell it out to people that, you know, here's where we're going to be, but if the weather proves differently, you've got to decide whether you're going to stay. I mean, it's also possible that you say, oh man, it's going to be cloudy here, and you take off and you drive 100 miles down the road and get clouded out, and the clouds opened up where you left.
Right.
That can happen. That can happen. So it's a gamble whether you stay or leave in either case, and that's got to be, if at all possible, an individual decision.
Well, you were on the same Indonesian cruise with some of our Louisville Astronomical Society members. They said that the captain, on the morning, there was clouds, he just moved the ship.
Well, he was moving the ship anyway, because in the morning he wasn't in the path.
Okay.
So we were underway anyway, but he was using weather satellite data to see where the best weather prospects were. But he had certain constraints, like he didn't want to use more fuel than he needed, because that means the cruise company loses money. So there are economic issues involved in this too. And as soon as the eclipse was over, he turned around and we started heading to the next port of call. So it wasn't purely for the eclipse, but it worked out very well for us. We were lucky, and we had a good captain. Yes.
I wasn't clear from here. Can it occur anywhere in the sky? Is it generally directly overhead, or is it on the horizon? I mean,
It varies with every single eclipse, and it varies where you happen to be in the eclipse path. If for instance, with next year's eclipse, if you're in Oregon, the eclipse occurs not too early in the day, about 10 in the morning. So the sun is about 40 degrees above the horizon in the east. By the time it gets over to South Carolina, it's more like 3 o'clock in the afternoon and the sun is over in the west. So it really depends on where you are on that eclipse path. And if you were out at the extreme ends of the ocean, the eclipse is occurring at sunrise or at sunset. Yes?
So is the corona safe to look at all, or is it?
A great question. Is the corona safe to look at? Absolutely. The corona is safe to look at, and in fact, if you keep those eclipse glasses on during totality and look up at the corona, you won't be able to see it. Because those glasses are designed to keep direct sunlight out, and you can't see anything else through those glasses. So if you're worried about your eyesight, and if it's a clear day and not clouds, when the sun's crest disappears, it's safe to look at. And by the way, if you're around any other people and it sounds like somebody just landed a touchdown at the Super Bowl, that's a good clue too, that totality is. Yes, in fact.
Thank you for calling on me. My name is Eliza from St. Francis of Assisi, and I was just wondering what makes the eclipse pattern so irregular.
Makes it so what?
Irregular.
Irregular. Why are eclipse patterns so irregular? Well, if you dig deeply down into the mathematics, they're very predictable. But the problem is you're taking several different patterns and superimposing them on top of each other, and whenever something like that happens, the result looks random. And that happens in a lot of aspects of nature. You've just got a number of different cycles going on. You've got the cycle from month to month of full moon. You've got the cycle of the moon from its closest point to its most distant point from the Earth. You've got the cycle of where the moon crosses the plane of the Earth's orbit, as is another cycle. And you've got the rotation of the Earth, which is 24 hours, which doesn't fit evenly into those cycles. And you throw all of those together, and these eclipse paths look like scrambled all over the globe. But they're all predictable. Yes.
What is the probability of the two, there Carbondale, that 7-year stitch, what is that probability?
You know, I don't know. It's very unusual. It's very unusual for one particular place. But if you look at the 20th century or the 21st century, you will find many, many examples of where two eclipse paths cross within a decade or two of each other. So it's not that something is in the path very often, it's just it happens very rarely at one given point on the surface of the Earth. Certainly, it's the frequency of having two eclipses cross one place within a few years has got to be on the order of thousands of years. The probability of seeing an eclipse at any one given location, like Louisville, just one eclipse in Louisville, a total eclipse, or any city on the planet, is about, on average, about once every 375 years. But, you know, in some cases, like Carbondale, they're getting two in the span of 7.5 years. And other places might not get a total eclipse for 1,000 years or more. It's just the average is about 375 years. Yes?
Is there any after effect in the path of the eclipse once it's gone in terms of changes in the environment or the Earth?
Any changes in the environment? Nothing permanent. Animals go back to their daily routine that might be confused by the change in sunlight. There are some effects in the upper atmosphere because the sunlight isn't as bright, so it changes the ionosphere and some of the radio propagation, but that goes back to normal. I would say probably the biggest changes is a whole new generation of eclipse chasers will be born. So there's a big economic impact of people buying plane tickets to go to the next eclipse. Yes, in the back.
How would you prepare for a solar eclipse?
How do you prepare for a solar eclipse? Well, there are a bunch of resources up there. Some of them have personal accounts of what it's like to see a total eclipse. Some of them give practical information. There's stuff about eclipse photography. There's stuff about the frequency of eclipses. So there's a lot of material on the internet and stuff published in some of my books, which we'll have a table set up after the talk for our book signing. Yes, in the back. How do you predict it? Yeah, how do you predict where an eclipse is going to be? Well, we could have a whole lecture on that. That's a very detailed, complicated answer to it. But I will say you need to be able to predict very accurately where the sun is going to be, where the earth is going to be, and where the moon is going to be as a function of time. And then with that information, you can also predict the moon's shadow is pointing away from the sun. So you've got all the characteristics there, and now you have to sort of play that machine forwards in time and watch where the moon's shadow is, and wait till it sweeps across the earth and solve all the equations to determine exactly where it's going to be at any one instant. And that's where computers play a big role. I've done all these predictions for 5,000 years on a laptop computer. It doesn't require a big, powerful computer, but it requires a lot of detailed software and years of perfecting the software. Yes?
Thank you for calling me. I noticed in the pictures of the eclipse, the light from the corona was sort of, it has sort of strange shapes. How are those shapes affected by the electromagnetic field? What can affect how the light that is?
How is the shape of the corona affected by the sun's magnetic field? I'm sure you've heard of the sunspot cycle on the sun, where we go through this 11-year period where the sun gets a lot of sunspots, and then a period when it doesn't have hardly any or no sunspots at all. those have a big effect on the appearance of the corona, because the corona is affected by the magnetic field of the sun. The sun has a big north and south pole magnetic field like a bar magnet and like the Earth does, and that normally dominates